the boiler water circulation principle, and this video is presented by myself, and I'm Sriram. Why it's necessary for the water inside the boiler to circulate? It's very simple. If the water is stagnant, there will be uneven thermal stresses. What I mean is, one part of the water will be heated and other part will still remain as water, and steam and water mixture will not allow the steam formation in a proper way, thus increased fuel consumption and overheating of tubes. Let's now see a simple boiler design. Here we have the steam and water drum, where the feed water inlet is here, and here is the downcomer. Please note this point. Here is the downcomer. It's inside the boiler, or it's called as internal downcomer, and these are the generating tubes or the risers which produce steam, and then it's back to the steam and water drum. The steam which is formed is getting collected at this space, and steam outlet is over here, and here is the burner. The exhaust gas flows through the stack. So the previous design of the boiler had the internal downcomers, with which the cold water after the feed water inlet enters the internal downcomer, and then as it gets heated up, its density decreases and thus forms steam, and then rises up the risers, go through, and then get collected in the steam space. Let's see other picture and understand what is the design concept and what are the design changes in the recent generation boiler. And this picture is drawn by me, and this is a symbolic representation of recent generation boiler. Here you have an external downcomer. Assume this to be the boiler furnace refractory, and these are the generating tubes or the risers. Let's go back to this picture. So these are the risers, and here you have the steam and water drum. These are the external downcomers, which is outside the furnace of the boiler. So the feed water, which is entering over here, is getting collected over here, and then as it is cold when compared to the water or steam mixture which is inside the boiler, it comes down and gets collected in the water ring chamber, which is down, and then the cold water enters the furnace, and as it climbs up it becomes steam, and thus it rises up and then collects in the steam space. Later in this video we will see what are the advantages of having an external downcomer. Hope we all know the basic parts of a boiler. Let me explain in a short with this diagram. Here is the steam and water drum. For simplicity in understanding, we call this as a steam drum, and let this be the water drum, and the big pipe which is connecting the steam and water drum is the downcomer. Since the water flows in downward direction, we call it as a downcomer, and these are the riser tubes or the generating tubes, which means the water becomes steam. The water converts itself into steam and then rises up through these tubes and then gets collected in the steam space. That's why these are called as risers, and this is the furnace. And let's now go to the design principle. Why we have an external downcomer and what should be its size. So the design aspect is the ratio between the amount of steam leaving the riser and the amount of water entering the downcomer must be approximately 4:1. Let's get back to the picture and understand this. The ratio between the amount of steam leaving the riser and the amount of water entering this downcomer must be approximately 4:1, and at no point the riser tube must never be without water or never be full of steam. It should always have water in it. If not, it will lead to burnout and finally the rupture of tubes. So this is the design aspect. And now let's understand what happens if we have an internal downcomer. Let's get back to the previous picture and see what is an internal downcomer, just to recall. Alright, in this picture you have a downcomer, that is the water flows downwards, that's why it's a downcomer. You have inside the boiler or inside the furnace, that's why it's called as an internal downcomer. But in the recent generation boiler, we have the external downcomer, which is outside the furnace. So let's see what is the advantage of having an external downcomer. Alright, in the internal downcomer, what happens is the heat of the furnace heats up the water which is coming downwards into the riser tubes. As the water is getting heated up, its density decreases, which means the density difference between the steam formed and the water which is coming down is very less. So the circulation, that is the natural circulation, is impaired, or the natural circulation is affected. So we have an external downcomer. So let's now see what happens in an external downcomer. In the external downcomer, in the external downcomer, what happens is the cold water, relatively cold water, which has a higher density than what is inside the generation tubes, comes down. The density difference between the cold water and hot water over here is huge, so this naturally gets circulated. That's why it's preferred to have an external downcomer. So here is some of the picture of boilers which I worked on. The boiler shown over here is completely ripped off. We were doing some retubing work with some Greek fitters, so this picture was taken at that time. Let me explain some components which are visible in this picture. This is what the water ring, and these are the downcomers. What do you see over here? These come from the steam and water drum, and the downcomer brings the cold water to this water ring, and from the water ring you have tubes inside the boiler which generate steam and then puts it back to the steam drum. And what you see over here is the hand hole, and after emptying the boiler you can open this and clear the sludge out, and these are the blowdown valves. So we have two valves over here. These are the bottom blowdown valves. Let's see some more picture. Yeah, so this is another view of a downcomer, completely insulated. So one more picture, two downcomers which are huge in nature, just to maintain the ratio of 4:1. And just a top view from the top. See how big is the downcomer, connecting the water ring in the bottom.